page. I don't know which page. This is page 11, I think. Like 11. 6G solving cubic inequalities. So the mistake I have here is like this should be a plus to x, like I make it minus x. That's why the factor is incorrect. So if there's a plus to x, that needs to be a plus 3, and that needs to be a minus 1. So we have repeated factors here is x minus 1 squared times x plus 3. That's the mistake I made last time, and it will change the shape of the graph. So we won't have this graph here now. Okay, well, this might be still correct. So we will have I hope you still remember everything. Okay. We have x-intercept at 1, 0. So we have this point here, 1, 0, and x-intercept. We have minus 3, 0 as the x-intercept. And 1, 0, there are two factors here, so that will become a turning point. And we also have the y-intercept at 0, 3. We sketch the graph. From the right-hand side top because we have a positive leading term. So the shape of this graph will be there's a turning point here. So go pass through this point here and then go down here. Okay, roughly this should be the shape of the graph. So start from the top right and then pass through each point, and then 1, 0 is a turning point, and that's the only way we can sketch the graph. And we want the value less than or equals to 0. So we want it less than or equals to 0 is the negative, like these values, and negative values, negative y values. But there's also one point eligible. What point is that? Less than or equals to 0. Is there another point equals to 0? 1. So this will be the solution as well. So it's all the values here, including the negative 3. But you also need to get the 1 included as well, because that gives you 0. So less than or equals to 0. So therefore, x belongs to negative infinity to negative 3 inclusive union 1. Union 1. Okay, so that's just a mistake I want to correct with you first. And then we are going to learn next page. We are going to learn that's what we have done already. So finding rules, we have done all of that. So we are going to do 6i, which is page 14, please. Okay, 6i. Okay, quartic and other polynomial functions. So same as before, I have mentioned, when you sketch the factorized form of the cubic, I said this method also applies to all the other polynomials. If you can factorize all the polynomials, you can sketch them by the same method. So you start from either the top right-hand side or bottom right-hand side, and then go through each hole, and sum of the point will become turning point if you have even number of repeated factors. And if you have odd number of repeated factors, that becomes stationary point of inflection. So that's the two different things you need to pay attention. And all the other polynomials sketched in the same way. So the key thing is we need to factorize. Okay, so the key thing is we need to factorize. And then like same as cubic, there are two forms for the cubic. There was the stationary point reflection form and the factorized form. So same as the quartic. Okay, same as the quartic. So we have this form here. So for quartic, same as quadratic. we have turning point form as well. So the turning point form is almost exactly the same as the quadratic form, the quadratic turning point form. So it's y equals to ax minus h to the power 4 plus k. The stationary point of inflection form of a cubic is power 3, and for the quadratic is power 2, and this one is power 4, so that's a quadratic, so it's the turning point form. And the other one is the factorized form. So you need to factorize by yourself. Okay, you need to factorize the quadratic by yourself. So the first thing we're going to talk about is to sketch quadratic in the turning point form. So, well, there's really nothing to talk about for the quadratic. So there's only maybe one thing we need to pay attention. So how you find turning point form? You use the same method to find the turning point in quadratic, and it's exactly the same shape, except the bottom is a little bit flatter compared to x to the power 2. So this is the x to the power 4. I will sketch x to the power 2 on the same set of x's. The first question I want to ask is there any intersection between x to the power 4 and x to the power 2? Is there any point of intersection between those two graphs? 0, 0, that's one. Anything else? There should be. How do we solve point of intersection? Equate them. So when we equate them, what are the points you get? One, equate x to the power 4 and x to the power 2. What else? Yeah, how to solve x to the power 4 minus x to the power 2 equals to 0, and factorize x to the power 2 and x squared minus 1. And you can further factorize that by x plus 1 and x minus 1 and equals to 0. So how many points do you have? 3. So what are they? 0, 0. What else? 1, 1, right? And minus 1, 1. So there's 3 points of intersection. And you know the graph will twist if there's you see, you intersect at 0, 0 and intersect at 1, 1. The graph will twist. So let's say x to the power 2 if it's above x to the power 4, then after 1, 1, it will be below because you have a twist. You won't have graph like that. The graph, this shape doesn't make sense. So the graph must twist in between. So let's think about that. When x equals to 2, x to the power 4 and x to the power 4, which one is larger? X to the power 4 and x to the power 2, which one is larger when x equals to 2? 4 is larger, right? So x to the power 4 will be higher than x to the power 2. Therefore, the graph will look like this. Okay, so that's very important. We'll talk about that in a later section as well. But you need to understand why we have this twist, because I find 3 points of intersections. So if it's above the graph before, it must be below the graph after the intersection. And as I ask you, when x equals to 2, x to the power 4, which is this red graph, must be above this blue graph. It must be above this blue graph. Therefore, the blue graph must be above the red graph in between 0 to 1. And same as the other side. And that's why we have this blue one as x to the power 2. So this graph is x to the power 2, and the red one is x to the power 4. The thing you need to pay attention here is x to the power 4 is not always higher than x to the power 2. In between -1 to 1, x to the power 2 is actually larger. Okay, x to the power 2 is actually larger. So this is something you need to pay attention. But the thing is, the shape is quite similar to x to the power 2. It's only the bottom is a bit flatter compared to x to the power 2. And that's how we sketch it. So when look at this graph, x minus 2 to the power 4 minus 1, we know that the turning point must be 2, -1. Okay, that must be the turning point. And there's positive graph because there's a value is positive, so therefore it's like this shape. Okay, this is the shape, the upwards one. So let's put it down. Let's put it down. So we have 2 comma negative 1, which the point is here. And I'll roughly sketch it. It will be like something like that. Okay, so it's an upwards one. But I can see xy intercept. I need to work out xy intercept first in order to sketch it like more accurate. So I will start at x equals to 0. So I put f0. So it's minus 2 to the power 4 minus 1. What's minus 2 to the power 4? 16, and minus 1 is 15. So it's a pretty high point somewhere here. So I would say somewhere here. I put the point 15. All right. Now I'm going to solve for y-intercept, x-intercept. I have done the y-intercept. I'm going to sketch the x-intercept. So I make the whole equation equals to 0. So I have x minus 2 to the power 4 equals to 1. Okay, this is even power. When you take even root, you need to have the plus minus. So same as x squared equals to 4 was x. X can be plus 2 or minus 2. So power 4 has the similar property. You will have plus or minus. Because you times 2 4 times or negative 2 4 times, you get the same solution 16. So therefore, any even power, you take the even square root, even root, you will have plus minus. So what x minus 2 must be? Plus minus 1. Good. So that's something you need to pay attention and use right here. So it must be plus minus 1 because 1 times 1 times 1 times 1 gives you 1, or minus 1 times minus 1 times minus 1 times minus 1 gives you 1. The same as the square. The same as the square. So what x equals to? 2x, x minus 2 equals to 1, or x minus 2 equals to minus 1. So x equals to 3 or x equals to 1. So the coordinates is this point here and this point here, 3 comma 0 and 1 comma 0. This point is 2 comma negative 1. It's very similar to a quadratic. You can't really tell the difference. But the only thing you can try to make it like a little bit flatter here. But you're not always going to see the very flat bottom. So if you just sketch x to the power 4, you can't really see the difference between x to the power 2 and x to the power 4. So it's basically the same shape as a quadratic. And what's the range for this graph? Range? No. What's the lowest level? Negative 1 to infinity. Okay, so the lowest level is the lowest point you can get is negative 1. So it's negative 1 to infinity. All right, because I don't have enough time, I will let you just sketch example 2 by yourself, but this will be a downwards one. No, today, like after today. Yeah. I will try to go through all of it. All right, so now I'm going to solve for x to the power 4, like the quadratic equation. So remember, anytime I ask you to solve any polynomial equation, the first thing you want to think about is to factorize. Okay, the first thing you think about is to factorize. And for this whole chapter, the key idea is you need to know how to factorize. If you know that, you can sketch, you can solve. So the first 3 questions are really easy. I'm not going to spend a long time on this one. So I'll just do maybe the second one. Because there's no constant term, so what's the highest common factor here? 2x squared. So I will take 2x squared out, and you have x squared minus 4. That equals 0. And then that's 2x squared, x plus 2, and x minus 2. And that equals to 0. So x equals to 0 or x equals to plus minus 2 will be the solution. And the first one, the third one will be solved by the same method. We just remove that. It's not remove, take the highest common factor and factorize that. Yeah, so it's easy to factorize. Alright. Now show a little bit complex one. So when there is constant term, what we should do. Okay, when there is constant term, what we should do. Okay, let's have a look at this one. Second one of the next question. The first one is easy because first one I can factorize x to the power of 2 out first and then factorize the quadratic. So I'm not going to show that one. So I'll talk about when there is there is constant term and I can't take x or x squared out, what we should do. So for this one, do you remember how do you factorize the cubic? No? Okay, try to remember that. Give you 2 seconds. Yeah? Yeah. And then what's the first thing what you need to try? Yeah? The leading term, right? So that's the first thing we will do. So okay, let's like everyone said it's correct. So same to do with the quotient. So we need to put this table and you realize there are some missing terms in between. So what we have is x to the power 4 is 3. And what's the next one? 0. What's the next one? Negative 13 and 0 and 4. Okay, we have one more column compared to the cubic because it's quoted. Okay, 4, 3, 2, 1, 0. So 5 numbers. So I must put the 5 numbers down. And then the value we want us to try is plus minus 1, plus minus 2, plus minus 4 from here, and plus minus 1, plus minus 3 from here. So basically what we can try is plus minus 1, 2, 3, 4. I ask you a horrible question. If all of this number doesn't work, what we should do? Rational root theorem. So give me one possible value if it doesn't work. 2 over 3 or 4 over 3 or no. A third. Okay? A third, 2/3, and 4 over 3 plus minus of those values. But like it's not a horrible story for this one. You will try the positive integers and it works. Okay? It works. So give me a value, like anything you think worth it to try. Okay, do you think 1 worth us to try or negative 1? Do you think we'll start with that? 3, negative 13, and 4. Do you think they can give you a 0 by any addition and subtraction? No. So we're not going to try 1 or negative 1 because you still have the coefficient there, and the coefficient is not going to give you a 0 by adding or subtracting. So try another thing. Give me something else. We can try that, but I don't think that works. Give me a smaller one. 2. Let's try 2. Okay, the first one will be, what's the first one? 3, then 6. Next one? Yeah, 12. Negative 1 and negative 2. 0. Okay, this one works. So, but this, remember, this is a quotic, right? So the factor fx will be x minus 2. 3x cubed plus 6x squared minus x and minus 2. This will be the factor left over. It's not a quadratic. So what else you need to do? Factorize again. So you need to factorize that cubic again. So you need to try another value. But the good thing about this table is, I'll just write it below here. And that's x minus 2. 3x cubed plus 6x minus x minus 2. Okay, what's the good thing? Okay, let me tell you what's the good thing. The good thing is you can use these numbers, like keep working at the next line. Because see the coefficient is 3, 6, negative 1. 2. If you want to give another table for that cubic, it's exactly those 4 numbers. So I can just use like a next line to try another factor. Okay, to try another factor. Because it will be the same as you set up another table. See, 3, 6 minus 1 and minus 2. It will be exactly the same as you set up this table, but I can use the previous table to keep working. That's the good thing about this table here. Okay, try another number. Give me another value to try. If 3 doesn't work at the first place, it won't work for the next one. So it must be a factor for the whole function. So 1 doesn't work. Remember, I have proof 1 doesn't work. Because 3, negative 30, and 4 doesn't make a 0. I want negative 2. Yeah. I'm about to write it and then there's that 1, and I'm explaining why 1 doesn't work. Okay, you are correct. Okay, so we have 3 here. Then negative 2 times 3 is negative 6 plus the 6 we get 0. 0 times negative 2 is 0. 0 plus negative 1 is negative 1. Negative 1 times negative 2 is 2. 2 plus negative 2 is 0. So this one works. So what we have here is x minus 2 and x plus 2. Because I have to find another factor from this minus 2 here. And then we have 3x squared minus 1. Okay, it's 3x squared minus 1. Therefore, we have x minus 2, x plus 2. And this one will be root 3x minus 1. Okay. How many, if you finish factorize that, you have 4 factors, and I want to solve fx greater than 0. What do you need to do if I want to solve fx greater than 0? Okay, everything I have teach you in this booklet, you will be on your test. Okay, so everything. What do you need? You're trying to factorize, you're not going to combine it. You can do that, no problem. Yeah, how do we sketch it? All right, what's the x-intercept? Give me the 4 x-intercepts. 2, yeah. Yes, and what's the y-intercept? What's the y-intercept? Y-intercept? 4. Yeah, so first number here, last number here, 4. So you have y-intercept at 4. All right, where should I start? Right hand side top or right hand side bottom? Top. So it's about the W shape. It's a W shape. And what do I want? I want fx bigger than 0. Okay, I want fx bigger than 0. So it will be these values. these values and these values. Okay, so it's three different sections. There's three different sections. So x belongs to negative infinity to negative 2, exclusive, union that, union to infinity. I'm thinking, what time we finish? 35, right? All right, everyone. Can you go to page 17 first? Boys? Page 17, please. Yeah, like 6 hours is a really long one, but like it's basically combined for all the exercise. So it's inequality as well. Again, I'm just showing you a different shape of the graph. This one will be easy. So I want to solve inequality for fx smaller or equals to gx. Okay, so I want to solve fx smaller or equals to gx. So fx is x to the power 4. Smaller equals to gx. Gx is 2x to the power 3. So, what we want to do is solve this inequality. But as I said, solve inequality, I need one side to be 0 first. Okay, one side to be 0 first. So it's x to the power 4 minus 2x to the power 3 less than or equals to 0. What I need to do next? Yeah. Factorize. So what do you can factorize? Like what's the factor? X cubed. Good. So this one's easy to factorize because you have the highest common factor as x cubed. Okay, so how many linear factors do you have? No, more than that. More than that. 4. X to the power 3. X to the power 3, that's 3. X, that's 3 linear factors. And then x minus 2, that's the false one. So there are 4 linear factors here because it's a quotient. Alright, this one is interesting because the shape. Again, I'm going to show you the shape. What's the x-intercept? If you also see the x-intercept, what's the x-intercept? 0 and 2. Okay, y-intercept is 0 as well. So it's 0 and 2. Okay, so we have 0, 0 and 2, 0. Okay, question. If you have odd number of repeated factors, what that point will become? Okay, stationary point of inflection. Even times, 2 times, 4 times, that becomes turning point. 3, 5, 7 times becomes stationary point of inflection. Okay, so it depends even times, all times. So 2 is a normal point, so no problem for that. Do I start top or bottom? Top, right? It's positive, so it's top. So the point will be, okay, go through that point. And I need to go back to this point. But this point is a stationary point of inflection. So the shape will be like that. It still passes through the 0, 0, but it twists a little bit at the point 0, 0. So it becomes a stationary point of inflection. It's only turning point of stationary point of inflection. It depends even number of repeated factors or odd number of repeated factors. So say it's x to the power 5, the graph looks exactly the same shape as this one. So it's only even or odd. You only remember two different things. Even is turning point. Yeah, turning point, and the odd is this shape. Yeah, that's the only two different things we have. Okay, And we want smaller, like smaller equals to 0. So what x belongs to? Yep. So x belongs to 0 to 2. Just like the state. Yeah, that's the point. Okay, 0 to 2. Okay. And let's go to the previous page, please. Okay, here. Even function and odd function. Just write two explanations next to it. So what is even function? The actual definition, let's say the actual definition, like the formula, the proof is f minus x equals fx. I will show you this later. But graphically, if you look at the graph, what is even function? This is symmetrical about the y-axis. Okay, symmetrical about the y-axis. So, for example, x squared minus 2, that will be an even function. So if the graph is symmetrical about the y-axis, that will be the even function. Okay? And what is an odd function? Odd function, the definition is here. F minus x equals to minus fx. But this is symmetrical about the origin. So what we have is a cubic. That's symmetrical about the origin. Okay, so graphically, if it's symmetrical about the y-axis, you will have even function. If you have symmetrical about the origin, you have the odd function. But you need to also remember the two definitions here. So by definition, what's an even function? An even function is f negative x equals to fx. What's an odd function? Odd function is f negative x equals to negative fx. So that's the actual definition for even and odd function. But graphically, if you look at the graph, these two are the explanations for even and odd functions. I will just show you how to find even or odd function. Okay, how to prove it. Like if you don't have the graph, how we can prove that? Or when I say fx equals to negative f negative x equals fx, you should realize this graph is an even function, and you should also realize this graph will be symmetrical about the y-axis. 2 years ago, the VCA exam, there was one question testing about the even functions. So they haven't give you the rule for fx, they just tell you f negative x equals fx, and then they ask you a lot of properties after that. So you need to realize that's an even function. So that's why I emphasize this like last year and this year, because I have seen that in the VCA exam, and that's something expect you to know. So if you can go to the next page, okay, I have about like 5 minutes. I can finish discussing this one. If you go to the next page, I want to ask you, these four functions, are they even functions or odd functions or neither? So what I need to do, okay, if you look at the definition, those two definitions is all relate to f negative x. So I want to see what's happening to f negative x first. So say I give you the rule for fx. Let's see what's happening to f negative x. So let's sum f negative x in. Okay, so I need to really do the substitution. So that's 6 negative x to the power 4 minus 3 negative x to the power 2. And f negative x equals to 6x to the power 4 minus 3x to the power 2. Because minus to the power 4 is just becomes plus. So it goes back to the same function as before. So f negative x and the right hand side is just fx. Therefore, I have seen f negative x equals to fx. Therefore, that's an even function. Uh, there's another, like, it can either equals fx or equals to negative fx. So the next example will be the odd function. Boys, just be quiet for 2 more minutes. G negative x. Okay, so still I'm testing the negative x, what's happening. So this one, because the power is odd, okay, the power is odd. Like all of these powers are odd powers. So what I have here is that's negative 3x, and that's plus x power 3 and minus x. And you can see all the sign have changed. See, compare, well, if I take the negative sign out, if I take negative sign out, then this function is exactly the same as the original one. So I'll say that equals to negative g of x. So I want to relate that to g of, like, the original function. So n is the same as the original, or is the negative of the original. So it satisfies the negative of the original, therefore that's an odd function. Okay, therefore it's an odd function. Yep, like the false one will be neither. Okay, the false one will be neither. If you can, well, I think you roughly know, like the power needs to be either all even or all odd, and it can become even or odd function. But for this one, like part of it is even, part of it is odd. Therefore, what I get is x squared minus x. It's not exactly the same as mx, or it's not the same as negative of mx. So this one will be neither. Yeah, that will be neither. Okay, so that's it for 6i. Okay, so that's it for 6i. During the weekend, I will suggest you to do 6j as well by yourself, because there's only one example I'm going to show you in the class, and I don't want to spend long time for that exercise. I'll give you a lesson for that as well, I think. Like Monday, if I give you Monday, I need like 5 lessons. Yeah, I think I have enough time, so I'll give you a lesson on that. So Monday, I'll go through one example, and you need to fully complete chapter 6 and the homework. Okay, so your homework, I'll collect your homework on Monday. Homework, holiday homework. Okay, and the book work needs to be keep up to date. And we'll start next chapter like on Wednesday after you finish the quiz. Because it's not even, not odd. It doesn't equal to mx. See, this one doesn't equal to mx or doesn't equal to negative mx. So that's